वेलकम बैक टू माय डियर फ्रेंड्स। आप सभी को टेक सिविल लर्निंग में स्वागत है। एज यू नो, आवर चैनल इज कंटिन्यूसली इंसिस्टिंग विद प्रोवाइडिंग द प्रैक्टिकल एजुकेशन टू द स्टूडेंट्स so that they can understand the concept very easy and very clearly. So without wasting time, let's start the today topics which is mentioned in the thumbnails. My dear friends, I promise you, just give me your 30 to 40 minutes times. You will surely going to understand the concept which is mentioned in the thumbnails, right? So means just give me your 20 to means 30 to 40 minutes time, that is enough. And please watch the video till last so that you can understand the concept very clearly. So let's start without wasting time. My dear friends, today we'll talk about the viscosity. We have already discussed about the different properties of the fluid in the previous lectures. So in the same manners, today we'll discuss about other different properties of the fluid, that is viscosity. Right, as the viscosity is very interesting properties of the fluid. My dear friends, let's understand this concept very clearly. Viscosity कुछ नहीं है. Viscosity is also a properties of fluid. क्या है? एक properties of fluid है which offer the resistance, right? It is the property of the fluid which resist the flow of fluid. ठीक है, जो means क्या बोलता है, फ्लूड का फ्लो होने से, ठीक है, फ्लूड को क्या होगा, एक रेसिस्टेंस फोर्स फील होगा. ठीक है, दैट रेसिस्टेंस प्रॉपर्टी इज नथिंग बट द विस्कोसिटी. सपोज मान लीजिए कि ये एक सॉलिड बॉडी, राइट? इमेजिन दिस वन इज अ सॉलिड बॉडी एंड if you keep water on it, then the water start following even means what you call even in the even with a small force, right? means अगर हम लोग इस पे वाटर means इस पे वाटर हम लोग रख दिए and then water starts following, then my dear friends, the waters which is in contact with the boundary layers feel the more resisting force, right? Means here the flow of what you call liquid is very less, means the speed of flow of liquid at the boundary layer is very less. सो समझिए इस बात को. लेकिन हम लोग जितना मीन्स इस बाउंड्री लेयर से ऊपर जाएंगे, देन द स्पीड ऑफ द फॉलोइंग द लिक्विड इज हाई, right? So because here in the upward force in the upward layers what you call the resistance force is very less in compare of the boundary layers. So what I mean to tell you that the resistance force at the boundary layer is very high in compare of the that ones in the other adjacent layers. So what are the causes of viscosity? My dear friends, there are many causes of the what you call viscosity. The mainly causes is cohesion force, right? And I have that is cohesion forces and intermolecular momentum transfers. These are the two reasons for the arising of the viscosity. Here let me tell you about the cohesion force. My dear friends, cohesion force is nothing but it is a force which is acting between the molecules of the same medium. ठीक है, कोहेशन फोर्स इस टाइप का फोर्स है जो क्या बोलता है, एक मोलिकुलर अट्रैक्शन फोर्स है. ये मतलब सेम मीडियम में लगता है, राइट? लाइक वाटर्स, लाइक if suppose imagines the bag of water, this one's waters, then the water must have cohesion forces, right? वाटर को क्या होगा, अपना ही एक कोहेशन फोर्स होगा, दैट मीन्स एंड द कोहेशन फोर्स होल्ड द अट्रैक्शन बिटवीन, होल्ड द व्हाट यू कॉल मोलिकुलर अट्रैक्शन बिटवीन द वाटर्स. So that is nothing but the cohesion force. So cohesion force is a type of force which is acting between the molecules of the same mediums. So what happen, एक कोहेशन फोर्स का कारण से क्या होगा, विस्कोसिटी डेवलप होगा, राइट? ड्यू टू द कोहेशन फोर्सेस द मोलिकुलर अट्रैक्शन बिटवीन द एनी सब्सटेंसेस और एनी फ्लूइड्स what you call increases, right? If the cohesion force is more, then of course there will be the what you call arising of the viscosity takes place. At the same time, so the viscosity in the what you call gas, right? The viscosity in the gas is very less in compare of the viscosity of liquid. This is why, because the cohesion force between the what you call the cohesion force molecular between the gas is very less, right? आप इसको इस तरीके से समझिए. कोहेशन फोर्स का अगर सिंपल मैं बोलूँ तो जो मोलिकुलर अट्रैक्शन को भी बॉडी में होता है ना, ठीक है, लाइक व्हिच होल्ड द मटेरियल्स. सो लिक्विड में ज़्यादा होता है. देखिए सॉलिड में तो सबसे ज़्यादा होता है, राइट? द मैक्सिमम कोहेशन फोर्स एग्जिस्ट इन सॉलिड, देन द लिक्विड, देन इन गैसेस. इन गैस द कोहेशन फोर्स इज वेरी लेस, right? So that's why the viscosity in the what we call in the gases very less in comparable the liquid. So that is due to the cohesion force what you call arising of the viscosity takes place. Similarly, intermolecular momentum transfers. Here we can also say molecular momentum transfer. As you know, momentum is nothing but the mass into velocity, right? So it is the product of mass and velocity. So if the means there is a means momentum of the transfer between the molecules, so automatically the arising of or develop of the viscosity takes place. So let's understand this concept means very clearly, my dear friends. Here as you can see, I have imagined a solid body, right? This one is a solid body, and I have allowed means a flow of liquid, right? Means a flow of liquid takes place, right? As you can see here. So my dear friends, as I have told you that what we call means at the boundary layers, means we can say that means initial speed of the or the means velocity, means we can say the velocity of the water is 0, right? As you go upward, then the velocity of the fluid increases. So as you can see here, the velocity is 0, and as if you go upward, then the automatically velocity increases, because the cohesion means what you call the viscosity of the materials or the any fluid means हम लोग ऊपर जाएंगे देन कम होते रहेगा. सो वी कैन से दैट means here at the boundary layer the means what you call the resisting force is more, and if you go upward then the resisting force slowly decreases, right? So as you can see, this curve is nothing but the velocity means profile, or it is also known as velocity distributions curves. So as you know, means velocity means of the different points is means what you call difference, right? हर जगह पे velocity अलग अलग है, ठीक है. यहाँ पे velocity कम होगा, ठीक है. इससे ऊपर जाएंगे देन थोड़ा मीन्स ज़्यादा मिलेगा, इससे ऊपर जाएंगे देन थोड़ा ज़्यादा मिलेगा. सो द वेलोसिटी डिस्ट्रीब्यूशन इज डिफरेंट एट द डिफरेंट प्लेसेस. सो दैट्स वाई आई हैव इमेजिन द मीन्स 2 point that is A, this point is A, and similarly I have considered the one more point that is B. Up to the means up to height A it is considered as Y, as and up to the means height B I have considered Y plus dy, right? As the means height of this one is nothing but the dy. So up to B it is Y plus dy. So similarly here as you can see, the means velocity at the boundary layer is 0, right? And these ones I have just drawn one perpendicular line to the means verticals perpendicular to the solid boundary, right? So that it can means it can make you easy to understand. So उम्मीद करता हूँ ये डायग्राम आपको समझ में आया हो. चलिए इस पिक्चर को थोड़ा बड़ा करते हैं. लेट्स मेक दिस पिक्चर्स लिटिल बिग. So as you can see, the distance between this solid plate to this one's layer is means y, and this one's here, the suppose imagine the means velocity of means fluid here is u. Then of course I have told you while you move upward or forward then the velocity increases. So that one is y plus dy. माय डियर फ्रेंड्स, हम लोग इसको प्रैक्टिकल लाइफ में भी देख सकते हैं, ठीक है. मीन्स कोई मीन्स आप किसी भी सॉलिड मीन्स किसी भी मीन्स ज़मीन का सतह पे पानी गिरा दीजिए, देन जो पानी जो ज़मीन का सतह पे या मीन्स कोई सॉलिड बॉडी पे रहेगा, देन वहाँ पे क्या होगा, मीन्स पानी उतना फॉलो नहीं होता है, लेकिन ऊपर का पानी क्या होता है वो फॉलो होता रहता है, ठीक है. तो नीचे का पानी फ्लो क्यों नहीं होता है, क्योंकि वहाँ पे रेसिस्टिंग फोर्स डेवलप हो जाता है, और उसी रेसिस्टिंग फोर्स प्रॉपर्टीज को विस्कोसिटी बोला जाता है, ठीक है. सो यहाँ तक का जो हाइट बी तक का वाई प्लस डी वाई, नीचे का वेलोसिटी यू है एंड अपवर्ड वेलोसिटी इज यू प्लस डी वाई. सो let's understand this concept very clearly. Here as you can see, I have imagined one solid plate, and I have told you even at the small means magnitude of force, हम लोग means small magnitude force अगर means कोई भी liquid में लगाएंगे, if you apply a small magnitude of force then it's continuously it starts deforming, right? Even in the small magnitude of force it starts deforming. So as you can see here, I have applied a small means magnitude of force, that is df, right? Then it's continuously start deforming, right? And it will deform continuously. So it is very difficult to find out the what you call means deformations, right? Like we can easily find it on the solid plate. हम लोग क्या होता है कि solid plate में अगर हम लोग कोई भी force में shear force लगा रहे हैं, then हम लोग क्या करेंगे, उसको easily हम लोग पता लगा लेते हैं, ठीक है. मीन्स कितना strain develop हुआ, right? Means these angles is nothing but the strains. So we can easily find, we have already studied all these things in strength of the materials, but it is very difficult to find out means the deformation or the strain in the fluid. So that's why for finding the further actions we consider Newton law of viscosity. So Newton law of viscosity gives means the means what you call the formations of the viscosity. So let's understand this concept. So my dear friends, I have here I have applied one small what you call force. Then suppose I have imagined this ones here, that one is d theta and height is dy. As you know, means this concept is related with the time, right? So here du is nothing but the what you call speed, and d is with respect to time, so du into dt. Here shear force is applied, that is F by A, and as you know according to Newton's law of viscosity, Newton law of viscosity क्या बोलता है कि stress, the shear stress of fluid is directly proportional to the rate of shear stress. This is, means this statements is given by what, the Newton law of viscosity. The Newton, once again, the Newton law of viscosity states that the shear stress of a fluid is directly proportional to the shear strength. So I have considered this tan theta, then tan theta is nothing but P by B. So here if this one is 90 degree, then P is du dt and the B is nothing but the dy. So as the d theta is very small, means in हम लोग इसको रियल लाइफ में भी देख सकते हैं, मीन्स जो इसका डिफॉर्मेशन होगा, एंगल डिफॉर्मेशन होगा, बहुत ही कम होगा. सो d theta is very less, so we can replace tan theta equal to d theta, right? It can be easily understood. So d theta is equal to du by dt, du into dt by dy. So if you means bring this dy in the down of d theta, then d theta by dy is equal to du by dy. Here du by d theta, here that means du is nothing but the change in velocity. I have told you that as means if you move to the upward, the velocity of the fluid increases. So du is nothing but the change in this, du is nothing but the change in velocity of what, change in velocity of fluid. ठीक है, du क्या है, मीन्स जो मीन्स वेलोसिटी चेंज हो रहा है फ्लूइड का वो है. एट द सेम टाइम्स dy इज द डिस्टेंस फ्रॉम द वेयर बाउंड्री लेयर. ठीक है, जो बाउंड्री लेयर का जो डिस्टेंस था, ये जो इधर से इधर का जो डिस्टेंस था, इस डिस्टेंस क्या y है. सो dy इज द चेंज इन डिस्टेंस. एट द सेम टाइम्स d थीटा by dt is nothing but the rate of shear strength which represents the theta, right? In the above figure, as you can see here, my dear friends, here as you can see here, d theta represents d theta by dy represents what, the rate of change of shear strength. So the rate of change of shear strength is du by d theta, and we can say that the rate of shear strength is equal to velocity gradient. This whole term is known as what, velocity gradient. So velocity gradient is nothing but the change in velocity with respect to distance. दिस वन इज चेंज इन वेलोसिटी व्हाट, विथ रिस्पेक्ट टू डिस्टेंस. ये डिस्टेंस का रिस्पेक्ट में इसका वेलोसिटी चेंज हो रहा है. जो जो ऊपर हम लोग जा रहे हैं सॉलिड बॉडी से, तो वेलोसिटी ऑफ फ्लूइड इंक्रीज हो रहा है. सो वेलोसिटी, दिस इज ऑल्सो नोन एज वेलोसिटी ऑफ ग्रेडियंट. सो वेलोसिटी ऑफ ग्रेडियंट इज नथिंग बट द चेंज इन वेलोसिटी ऑफ द फ्लूइड विथ रिस्पेक्ट टू डिस्टेंस इज नथिंग बट द वेलोसिटी. So ultimately shear strain is equal to velocity gradient, and in the means what Newton's law states that shear stress is directly proportional to velocity gradient or the rate of shear strain. So the according to what, the Newton's law of viscosity, right, the shear stress, I can say shear stress directly proportional to the rate of shear strain. So this one is also equal to the velocity gradient. So I can replace d theta by dt with respect to du by means dy. So velocity means shear stress is directly proportional to du by dy, right? So I means if I replace the means if I make the equal to, then I must replace or equivalent with the du. So du, this one is known as mu, so it means here tau is equal to mu into du by dy. Here the mu represent nothing but the dynamic viscosity of fluid. So d means mu is nothing but the dynamic viscosity of fluid. So this is the equations which is given by the Newton law of viscosity. So the Newton law of viscosity equal to shear stress equal to mu into du by dy, where the mu is dynamic means viscosity of what, fluid. So it means if you need to find means mu, then we can also find mu is equal to, right, tau by that is means velocity gradient du by dy, right, du by dy. So here you can see means the dynamic viscosity means formula, dynamic viscosity is equal to, right, mu, right. Here then this one is shear stress, and the shear stress SI units is Newton per meter squares, and at the same times means mu is remain as mu. Here this one is nothing but the change in velocity, and the velocity formula is meter per second. So meter and the per second is nothing here, meter per second is nothing but the dy, and the d means du, and the dy is nothing but the distance. The distance must be in meters, so this meter cancel. Then if you means brings this s into that side, then n into s by meter square. Here the newton into second second per meter square is equal to what? Dynamic viscosity. So dynamic viscosity SI unit is Newton second per meter square, and also my dear friends, Newton per meter square is also known as 1 pascals. So the dynamic viscosity can be also written as Pascal product of in seconds, right? So it can also Newton second per meter square is the SI unit of dynamic viscosity. And in the CGS unit, that means in CGS systems means shear stress is done by centimeter square, right? So if you, and this one's distance means velocity is centimeter per seconds, and the distance is centimeters. So ultimately dyne's product of second by centimeter squares, and this is known as poise. So the means if anybody asks you, अगर आपको कोई पूछेगा कि मीन्स डायनामिक विस्कोसिटी को CGS यूनिट का यूनिट क्या होता है, तो क्या होता है? वो पॉइज होता है. और 1 पॉइज इक्वल टू क्या होता है? 1 के पावर 10 मीन्स 1 पर 10 न्यूटन सेकेंड पर मीटर स्क्वायर और पास्कल सेकेंड. सो याद रहे कि 1 पॉइज में 1/10 क्या होता है? पास्कल सेकेंड होता है. ये न्यूमेरिकल में ये चीज़ ध्यान रखना बहुत ही जरूरी है. From these statements we can say that shear stress is inversely proportional to the distance. ठीक है, means if the distance is less then the shear stress is high, if the distance is high then the shear stress is less. So this is all about the what we call Newton's viscosity. So let's talk about the kinematic viscosity, right? We have already discussed about means Newton law of viscosity, right? We have discussed about the dynamic viscosity units. Now we'll discuss about the kinematic viscosity. Kinematic viscosity is represented by a small v. So it is nothing but the what you call the ratio of dynamic viscosity means to the mass density of the fluid. So this one says mu by means density of fluid. This is nothing but the kinematic viscosity. So kinematic viscosity is the ratio of dynamic viscosity to the mass unit of fluid. So it is the ability of the fluid to diffuse the means what you call distributions in the molecular momentum. So this represent means these ones. As you know, the SI units of means let's say means units of means what we call kinematic viscosity means the means SI units of kinematic viscosity. You can easily means what you know the unit of this one is Newton second by per meter square, right? And the density is nothing but the what we call meter cube. So ultimately we will get the SI units of these ones means kinematic viscosity. So that is meter square seconds, right? So that means what we call kinematic viscosity SI unit is meter second square. In the CGS unit it is a stroke, right? So 1 stroke is equal to 1 into 10 to the power minus 4 meter square per second. So remember, if anybody asks you what is the means CGS unit of kinematic viscosity, then it is a stroke, and in 1 stroke it is equal to 1 into 10 to the power minus 4 meter square per second. So this is all about the means what you call viscosity. Let's see means some of the means what you call temperatures effect on the dynamic viscosity. My dear friends, what you call the means dynamic viscosity of the liquid decreases with the increase in temperature. क्या होगा means जब temperature बढ़ेगा ना तो मीन्स जो डायनामिक विस्कोसिटी है वो कम हो जाएगा, ठीक. और कम कैसे होगा? मान लीजिए कि एक मीन्स फ्लूइड है, ठीक है. व्हेन वी हीट द फ्लूइड देन व्हाट हैपन, द मोलिकुलर अट्रैक्शन बिटवीन द फ्लूइड मीन्स डिक्रीजेस, राइट. इफ द मोलिकुलर अट्रैक्शन बिटवीन दिस वन से डिक्रीजेस, अगर उसका मोलिकुलर अट्रैक्शन डिक्रीज हो जाएगा तो ऑफकोर्स उसका क्या होगा? विस्कोसिटी डिक्रीज हो जाएगा, ठीक है. अगर विस्कोसिटी डिक्रीज हो जाएगा तो वो इजीली फॉलो करता है, ठीक है. मान लीजिए एक आइस और एक मीन्स इट्स मीन्स कोई भी मीन्स गारा फ्लूइड मीन्स व्हाट यू कॉल्स the visco means any fluid is having the high viscosity means it is means its molecular attraction is very high. So if you heat that once means what you call fluid, then what happen, the molecular attraction between that fluid means is destroying, right. उसका मीन्स जो मोलिकुलर अट्रैक्शन होगा वो डिस्ट्रॉय होगा. जब भी उसका मोलिकुलर मीन्स अट्रैक्शन उसका मीन्स क्या बोलता है उसको मीन्स डिस्ट्रॉय हो जाएगा, देन क्या होगा उसका मीन्स जो मीन्स काइनेमेटिक विस्कोसिटी है वो भी डिक्रीज हो जाएगा. सो वी कैन, एंड ये जो है एक मीन्स जनरल इक्वेशन से भी हम लोग देख सकते हैं, दैट मीन्स म्यू 0/1 plus alpha into means t and plus beta into t, where the alpha and beta are constants, then we can easily see the means kinematic values means viscosity is inversely proportional to the temperatures. So जब मीन्स कोई भी पानी को अगर आप हीट करिए, फ्लूइड को आप हीट करिए, देन क्या होगा उसका मीन्स मोलिकुलर अट्रैक्शन डिस्ट्रॉय हो जाएगा, और जब भी मोलिकुलर अट्रैक्शन डिस्ट्रॉय होगा देन उसका विस्कोसिटी भी डिस्ट्रॉय हो जाएगा. लेकिन गैस में क्या होता है, उल्टा होता है. ठीक है, अगर मान लीजिए अगर गैस में क्या होगा, इफ द टेम्परेचर्स इंक्रीजेस इन द मैटर ऑफ गैस, देन व्हाट हैपेंस, द मोमेंटम ऑफ द मोलिकुलर्स इंक्रीजेस. ठीक है, मोमेंटम इज व्हाट, मास इनटू वेलोसिटी. दैट मीन्स द स्पीड ऑफ द मीन्स व्हाट यू कॉल मीन्स शेकिंग ऑफ द स्पीड ऑफ शेकिंग ऑफ मीन्स गैस इंक्रीज है. ठीक है, क्या हो जाएगा, अगर आप मान लीजिए कि कोई भी गैस को, ठीक है, आप उसको हीट कर रहे हैं, देन उसका क्या होगा, मीन्स मोमेंटम इंक्रीज हो जाएगा, राइट. मीन्स देन मोमेंटम इंक्रीज हो गया, मीन्स काइनेमेटिक मीन्स जो विस्कोसिटी है वो इंक्रीज हो जाएगा विथ रिस्पेक्ट टू टेम्परेचर्स, एंड द इक्वेशंस एज पर द मीन्स जनरल इक्वेशन यू कैन ऑल्सो सी. सो दिस इज ऑल अबाउट द विस्कोसिटी एंड इट्स रिलेटिव कंसेप्ट्स. सो उम्मीद करता हूँ आपको विस्कोसिटी के बारे में जितना डाउट हो वो सब क्लियर हो गया होगा. अब देखते हैं कंप्रेसिबिलिटी. इट इज ऑल्सो द प्रॉपर्टी ऑफ फ्लूइड which is the reciprocal of the bulk modulus of elasticity, that is means B is equal to 1/k, where the k is bulk modulus of elasticity. So this is represented by the capital B. So the compressibility is the reciprocal of means modulus of elasticity, bulk modulus of elasticity, and its unit is meter square per newtons, and its dimension is means meter inverse m inverse LT ka power squares. So let's see about means this one is easy concept. Vapor means water vapors. Yes, water vapor can be easily understood. So as you can see, in the closed vessels at the constant temperatures, the fluid molecules break away from the liquid surface and enter into the space means surface, right. It means it is very relevant to our real lives, right. It means if we heat any means fluid, then what happens, there means there is a formation of steam takes place. That steam is nothing but the steam is the vapors, then the vapor transfer to the atmosphere, right, and again it falls in the form of precipitation. That is another things we will study in another subject. So that is nothing but the pressure vapors. So that is, it means so we can also define the pressure vapors in such a way that when you heat a fluid, then the steam takes place, right. That steam is nothing but the what means vapor. So here then in the closed vessels means, and what is vapor means vapor pressure in the closed vessel at the constant temperature. एक means closed vessel में अगर हम लोग continue means constant temperature उसमें लगाएंगे, then molecular attraction उसका क्या होगा, destroy होगा, ठीक है, और जो वो liquid होगा वो means gas का form में बन के निकल जाएगा. So this is all about the means what you call means vapor pressures. When the air above the liquid surface is saturated with the liquid vapors molecules, then the pressure exerted on the liquid, that pressure is nothing but the vapor pressures. So when we heat the liquid continuously, then there is a steam formations, and the steam formations which is saturated with the liquid surface, right, and that vapor molecules then means exert a pressures on the what you call on the liquid surface. That exerting pressure is nothing but the vapor pressures. So उम्मीद करता हूँ आपको समझ में आया हो, ठीक है. So vapor pressures increases with the of course means there is a more temperature, then the vapor pressures is more, ठीक है. अब मान लीजिए ना कि means if you have means मान लीजिए आपके एक कुकर है, ठीक है, कुकर में पानी है, आप उसको कंटिन्यू हीट कर रहे हैं, देन क्या होगा वो, अगर हम उसको मीन्स अगर सीटी जब नहीं लगेगा, अनटिल मीन्स जब उस सीटी नहीं लगेगा, देन क्या होगा उसका प्रेशर इंक्रीज होते जाएगा और वो ब्लास्ट हो जाएगा. सो दैट फिनोमेना इज नथिंग बट द वेपर प्रेशर्स. So the means pressure of the liquid is 2.3 kilopascals, and the pressure of the mercury is 0.16 kilopascals. So this one is all about the means vertical means vapor pressure. Now my dear friends, we have already almost discussed about all the properties of fluid, right, means like viscosity, relative viscosity, right, means compressibility, right, means what you call surface tensions. We have discussed about the viscosity, Newton law of viscosity, kinematic viscosity, dynamic viscosity. We have discussed about almost every properties means every properties of the fluid. So now it's time to deal with the some of the numericals problems. So let's see some of the numerical problems. Here the problem is in such a way, calculate the capillary rise, right. This one is capillarity, means it belongs to the properties of the fluid from the capillary tube. So calculate the means what you call capillary rise in the glass tube, right. means in the capillary tube, suppose this one is means what you call bucket of waters, then we insert one means less diameter one, insert one tube in that ones, right? If the surface of the water is this ones, right? So this is full of waters, means we have to calculate this one's height of the water from the surface of the means height of the tube, means sorry, how much height of the waters rises in these ones from the surface of the waters. So means calculate the capillary rise in the glass of 2.5 mm diameter. This glass is having dia 2.5. When it is immersed vertically in water A, it means there is two means fluid, one is waters and another one is mercury, means one bucket is filled with water and another is filled with mercury, right? And in both means 2.3 mm diameter is inserted, right? means मान लीजिए कि एक बकेट में पानी है और दूसरा बकेट में मरकरी है और दोनों में 2.5 mm डाया का मीन्स जो ग्लास ट्यूब है उसमें इंसर्ट किया गया है, ठीक है। देन मीन्स इधर क्या बोला गया है, मीन्स जो वाटर का मीन्स सरफेस टेंशन है वो 0.725 न्यूटन पर मीटर है। एट द सेम टाइम्स जो मीन्स मरकरी का है वो 0.52 न्यूटन पर मीटर है। देन इसके कैपिलरी राइज और कैपिलरी डिप्रेस्ड कितना होगा, ठीक है, वो निकालने को बोले, बहुत ही आसान है, राइट। हियर यू कैन सी मीन्स डायमीटर ऑफ द ट्यूब इज 2, सो फ्रॉम हियर and the surface tension is 0.725 newtons, right, and the surface tension of the mercury, right, mercury is 0.52. So the capillary rise formula is given by 4 into surface tensions into cos theta by density into gravity into means dia bar, right, that is means rho, right, G and D. So G means rho is nothing but the density and the G is, as you know, the means gravity, at the same times D is the diameters. So it means here see, here 4 is means no, here the surface tension is given and the cos theta. My dear friends, if in some of the numericals if the theta is not given, then for the waters, right, for the water glass means theta value is assumed to be 0 degree, right, and for the mercury it is assumed to be, in some of the textbook it is 120, in some of the textbook it is 130, right. So imagine 128 or 130, right. So here the theta value for the pure water is 0, right. So substitute these ones in the equations, right, and here the means rho G, we can also write rho G equal to W. Rho G we can write it W. So rho is nothing but the means that is the density of the standard fluid, or that is water is 1000 and the G is 9.81. So ultimately it come 9810 newtons. Then the diameter of this one is given, then 4 into that is surface tension into cos 0 divided by rho G, that is 9810 into diameter of the means what you call diameter of the tube, then the H is 0.118, means ये ग्लास है, ट्यूब ग्लास है, अगर यहाँ तक मीन्स मान लीजिए वाटर है, ठीक है, ये फुल ऑफ वाटर है, देन इसमें अगर वाटर यहाँ तक राइज हुआ, मान लीजिए यहाँ तक वाटर राइज हुआ, देन इसका यहाँ से लेकर यहाँ तक डिस्टेंस इज नथिंग बट दिस डिस्टेंस मीन्स 0.118. अब सिमिलरली अब मरकरी का केस में देखते हैं, ठीक है, इन द मरकरी सेम फॉर्मूला इज यूज्ड, हियर जस्ट डिफरेंस इज थीटा इज means 130, you can also imagine 128. So here means rho G, we can also means the what you called the density of the mercury is 13.6, right, and we convert it into Newton, then into 10 means into 1000 and into 9.81, so 133.14 means 416. Then substitute all this value in the, then it comes, when you solve whatever the value comes, that is the value of H. It may be the diffractions or the rises. So this one is the numerical, very means easy type of numericals is going to be asked. So let's see some of more numerical. Here means calculate the specific means weight, right, density and the specific gravity of 1 liter of the liquid which is weight 1 means 7 newtons, right. So we have to calculate the means weight, a specific density, a specific gravity and किसका 1 लीटर मीन्स लिक्विड का जो मीन्स वेट है मीन्स ऑफ ग्रेविटी ऑफ 1 लीटर मीन्स वॉल्यूम जो मीन्स 1 लीटर क्यूब, राइट, वॉल्यूम ऑफ द लिक्विड इज गिवन 1 लीटर्स and the weight is given 7 newtons. So here see the volume is 1 liter. So if you convert liter into meter cube, then divide by 1000. So 1 per 1000 and the weight is 7 newtons. So a specific weight is nothing but the weight by volume. As you know, weight by volume, the weight is given and the volume is given, so ultimately we can calculate directly by applying the formula. Similarly, density is given, that m by g. So density is nothing but the mass by volume. So mass can be also written as m, right? Means mass can be written as here. So my dear friends, as you know from the means what you call means weight density is nothing, is weight density is nothing but it is equal to, mathematically it is equal to density into gravity, right? So here we can directly calculate this density, right? That is density is equal to w by g. So we have all those value w, right, and we have g value. So w by g is means equal to means density. Even though we can calculate, हम लोग इसको ऐसे भी निकाल सकते हैं मास बाय वॉल्यूम, ठीक है. फिर मास को हम लोग क्या लिखेंगे, मास को लिखेंगे w, फिर इस टर्म में क्या है, मास का वैल्यू मीन्स इन द क्वेश्चंस द वैल्यू ऑफ मास इज नॉट गिवन, इट इज इन टर्म ऑफ वेट. So directly from this relations, that is means weight density is equal to gravity into density. From here we can easily calculate density, that is density is equal to w by g. Similarly, a specific gravity, in some of the questions a specific gravity is also given as relative density. So no need to confusion, specific gravity को ही relative density बोला जाता है. So the formula of this one is means density of liquid by density of standard fluid. So we have already calculated the density of what you call liquid, that is 700 means 713.55 divided by 1000, that is means the density of the fluid is 0.713. So hope आपको ये भी नोमेरिकल क्लियर हुआ हो. मीन्स इजी टाइप नोमेरिकल है. देयर इज नो मीन्स देयर इज नॉट मीन्स such a complex numericals that you will not going to understand. Means in the university level some of the means simple numericals is going to be asked. So let's see another type of numerical. My dear friends, understanding the numericals, understanding the concept of numerical is very essential. So let's see, if the velocity distributions of the plate is given by u is these ones, right? Means this type of numerical is related to viscosity. Suppose this one is a plate. So the here the u value, u as I have told you, means this one means initial velocity is nothing but given by 2 by 3 y minus y squares at a distance of y meter from the above the plate, right? And if suppose this one here is a plate and this distance is y, then the velocity of here is that one's the means at a y distance above the plate velocity v meter per second. Then determine the shear stress at y is equal to 0, that is at the means boundary layer, and equal at y is equal to right 0.15. So we have to determine what we call the means shearing means stress, right, at the means boundary layer. हम लोग यहाँ पे क्या shear stress निकालना है, एक बार boundary layer पे और एक बार उसका थोड़ा ऊपर, right. So means easy है, means here means velocity is given 2 by 3 y minus y square where u is the velocity, right. shear stress निकालना है कहाँ कहाँ पे, at y is equal to 0 means boundary layer पे, at y is equal to 0.15, right. Similarly kinematic velocity is means kinematic density is given, dynamic viscosity, mu is nothing but the dynamic viscosity, right. Here dynamic viscosity is given 0.8 sorry my dear friends, sorry for inconvenience, right. Here the dynamic viscosity is given 8.63 poise. It is in poise, then we must have to convert this poise into weight means SI unit, and I have told you means 1 poise is nothing but 1 by 10 Newton second per meter squares. So here let means if we means differentiate these ones with respect to y, because we have to differentiate as I have explained you in means previously, that ones the distance between this one is y, right, and this one's is dy, right, dy. So we have to find out du by dy. So if you differentiate these terms, then 2 by 3 is constant, it comes out, and y will be cancelled. Similarly y cube can be means differentiate as 2y. Hope आपको differentiation आता हो. So आसानी है, 2 by 3 constant इसको बाहर निकालेंगे, y तो ऐसे ही हट जाएगा, then y cube को क्या होगा 2y होगा. Sorry, it is not y cube, it is y square. If अगर यहाँ पे y cube होता, ठीक है, अगर यहाँ पे y cube होता देन क्या होता है 3y², ठीक है। और इसको फिर से डिफ्रेंशिएट करते हैं, ठीक है, मीन्स y का फॉर्मूला लाने के लिए। यहाँ पे ओनली y² है, देन क्या होगा, ये 2 है, इसका फॉर्मूला होता है, ठीक है, तो ये 2 नीचे आ जाएगा और y इधर आ जाएगा, सो 2y। सो वी होप आपको डिफ्रेंशिएशन आता हो, ठीक है। हेयर लेट्स कैलकुलेट द शियर स्ट्रेस एट द जीरो, ठीक है। पहला क्या है कि शियर स्ट्रेस कहाँ पर निकालेंगे, जहाँ पे जीरो है, ठीक है। तो एज यू नो here the shear stress tau is equal to mu into du by dy, that is given by Newton law of viscosity. So here means tau is equal to 8.63, it is in poise, right? If you convert this one's poise into Newton second per meter squares, then 1 power 10, the 1 power 10 is nothing but the 0.1, right, into means 2 by 3, then it comes whatever the answer will be, that will be the means stress value at the boundary layer where the means distance is 0, means at the boundary layers. Similarly at the distance of means 0.15, just substitute all this value in these equations, you will get the value. Here if you substitute the y value, then the means du by dy is come 2 by 3. If you substitute 1 means y value 1.5, then 2 by 3 minus 2 into 1.5, then here means formation of means what you call velocity gradient will be difference, then again means keep in formula of these ones and we need to solve. So no need to worry, आपको means टेंशन करने की कोई ज़रूरत नहीं। अगर y का वैल्यू जितना भी डिफरेंस दिया है, देन फर्स्ट क्या करना, मीन्स वेलोसिटी ग्रेडियंट निकाल लेना। फर्स्ट नीड टू फाइंड द वेलोसिटी ग्रेडियंट, देन उसमें y का वैल्यू सब्सटीट्यूट कर देना, देन सब्सटीट्यूट द y वैल्यू इन द वेलोसिटी ग्रेडियंट, देन अप्लाई द फार्मूला दैट इज टाउ इज इक्वल टू म्यू इनटू du by dy is the velocity gradient, then substitute the equations which you got or substitute the value which you got, then means substitute the mu value which it must be given in the means what you call, it must be given in the questions in the either it may be in Pascal second form or it may be in means poise forms, right? So in one poise equal to 1 by means 10 Newton second per meter square, so that you can calculate easily.